Hi everyone. In this video, we are going to derive the sine, cosine and tangent ratio of another multiple of angle which is 3 times of a. So we will derive what is the value of sine of 3 times of a in terms of the a angle. Similarly, we will also derive the value of cosine of 3 times a in terms of the a angle, and similarly the tangent of 3 times of a, right? So let's get started with the sine of 3 times of a. Can we write sine of 3 times of a as sine of 2 times of a plus a? And then we are going to use the formula of sine of a plus b. So that would be sine of a times cosine of b plus cosine of a times sine of b. When I say a and b, you can assume that this is a and this is b. So this is clearly sine of a plus b form. So that's the formula I just used. And then from here, let's try to expand sine of 2 times of a. We know that sine of 2 times of a is equal to 2 times of sine a times cosine a. And then also we have another cosine of a right here. So the sine of 2 times a converted into 2 times sine of a times cosine of a. And then this cosine of a right there is this cosine of a right here. And then we have the plus sign. Cosine of 2 times of a, that will convert into 1 minus 2 times sine square of a. So we can write here 1 minus 2 times sine square of a. We have already derived these values in the previous video. I have shared the link in the description. Feel free to watch that video. So cosine of 2 times of a can be written as 1 minus 2 times sine square of a, and then multiplied by, we already have the sine of a, which is actually this one, this sine of a right there. I simply wrote it right here. And this cosine of 2 times of a converted into 1 minus 2 times sine square of a. And now let's remove the parenthesis and see what happens. So the first term can be written as 2 times of sine of a times cosine square of a. And this cosine square of a can be written, so let me erase this. I'm going to replace the cosine square of a, this cosine square of a right here, I'm going to replace that with 1 minus sine square of a. And then here we have 1 minus 2 times sine square of a whole multiplied by sine of a. So if we remove the parenthesis, this will become sine of a minus 2 times sine cubed of a. And if we remove the first parenthesis here, this will become 2 times sine of a minus 2 times sine cubed of a. And then we already have plus sine of a, and then minus 2 times sine cubed of a. So from here, as you can see, we have 2 terms of sine a. There is 2 times sine a and then another sine a. So that will give us 3 times sine of a, and then minus we have sine cubed of a, 2 negative times here and another negative 2 times here. So that would be negative 4 times sine cubed of a. And that is the value of sine of 3 times a. Now let's derive the value of cosine of 3 times a. The method is pretty similar. So we can write that as cosine of 2 times of a plus a, and then let's use the formula of cosine of a plus b. So if we simply assume this as a and the other a as b, then this is clearly looking like cosine of a plus b. So let's use that formula. We know cosine of a plus b is actually cosine of a times cosine of b minus sine of a times sine of b. And then again let's expand the value of cosine of 2 times of a, which can be written as 2 times cosine square of a minus 1 times cosine of a. This cosine of a is right here, and then this cosine of 2 times of a, that is converted into this. And similarly we have minus, then for sine of 2 times of a, can we write it as 2 times of sine of a and cosine of a and times sine of a. So this sine of a right there, that is actually here, and then sine of 2 times of a has been written as 2 times of sine of a times cosine of a. And if we simplify this, what do we get? Well, from here we can say that this is, let's remove the parenthesis, so here it will be 2 times of cosine cubed of a minus cosine of a. And then we have another minus sign here, and this is actually 2 times of sine square of a times cosine of a. And then in place of sine square of a, can we write it like this? Well, let's keep the first portion as is. So we have 2 times cosine cubed of a minus cosine of a minus 2 times, for sine square of a we can say this is 1 minus cosine square of a times cosine of a, and this can be written as 2 times cosine cubed of a minus cosine of a minus 2 times cosine of a, and then plus 2 times cosine cubed of a. So this is looking like 4 times cosine cubed of a. If we combine this one and this one, we get 4 times cosine cubed of a, and then minus 2 and 1, 3 times cosine of a, and that is the value of cosine of 3 times a. Now let's also derive the value of tangent of 3 times of a. So tangent of 3 times of a can be written as the ratio of sine of 3 times a over cosine of 3 times a, and then we just derived the values of sine of 3 times a, which is actually 3 times sine of a minus 4 times sine cubed of a, and divided by cosine of 3 times of a is actually 4 times cosine cubed of a minus 3 times cosine of a. And now let's take out sine of a from the numerator. So this will be sine of a times, what are we left with? We are left with 3 minus 4 times sine squared of a. And similarly in the denominator, let's take out cosine of a, and then we will be left with 4 times cosine squared of a minus 3. And now we are going to divide both the numerator and the denominator by cosine square of a, and let's see what happens. So here we can say, well, this portion right here, this becomes tangent of a. So I'm going to write it as tangent of a times, then over here what I'm going to do, I'm going to divide this 3 minus 4 times sine squared of a, I'm going to divide that by cosine squared of a, and then whole divided by, we have 4 times cosine square of a minus 3, that too will be divided by cosine square of a, because we are dividing both the numerator and the denominator by cosine square of a, right? And then if we simplify a little bit how this is going to look like, so this will be equal to tangent of a times, in the numerator what we get? We get 3 over cosine square of a minus 4 times sine squared of a over cosine squared of a, and then whole divided by, in the denominator what we get? We get 4 times cosine squared of a divided by cosine squared of a, so that will become 4, so that will become just 4 minus 3 over cosine square of a, and then can we write it like this? This will be tangent of a times, in the numerator I am going to say that is 3 times secant square of a, think about it, and then minus 4 times tangent square of a, that's in the numerator, and then in the denominator we get 4 minus 3 times secant square of a, because 1 over cosecant square of a is equal to secant square of a, because they are reciprocal of each other. So then from here can we write it like this? This will be tangent of a times 3 times secant square of a, can be written as 3 times 1 plus tangent square of a minus 4 times tangent square of a, and whole divided by, we can write 4 minus 3 times 1 plus tangent square of a, and from here if we simplify a little bit, what do we get? Well, outside we have tangent of a times, in the numerator what do we get? We get 3 plus 3 times tangent square of a, and then minus 4 times tangent square of a, whole divided by, we have 4 minus 3 minus 3 times tangent square of a, and this can be written as tangent of a times, let's look at the fraction. In the fraction, in the numerator we have 3 minus tangent square of a, so that would be 3 minus tangent square of a, and divided by, it would be 1 minus 3 times tangent square of a, and now if we multiply the tangent of a with the numerator, so that would be 3 times tangent of a minus tangent cube of a, whole divided by 1 minus 3 times tangent square of a, and that is the value of tangent of 3 times a. I hope everything made sense. Thank you for watching. See you in the next video.